Hello students, welcome back to OrganiChemVerse. In our last video, we have covered the fundamentals of aldol condensation and walked through the detailed reaction mechanism. However, simply understanding the mechanism isn't enough. To truly master this reaction, you need to learn a powerful shortcut. That is, how to quickly write the final product structure in a single simple step. So, let's dive into that one-step approach. I have taken 4 different reactions. We will write aldol addition products followed by the condensation products. In aldol addition, we know that one of the molecules will act as electrophile, the other one will act as a nucleophile. The molecule which you consider it as an electrophile, right? You always make sure that that carbonyl will undergo reduction. That means it will reduce to alcohol like this. The double bond is forming a single bond here. This is for the electrophile. Then what about the nucleophile? We know that the alpha carbon is the one which is going to attack the carbonyl carbon. That means what? We usually remove the alpha hydrogen, right? So the CH3 will become CH2. What about the rest of the molecule as it is? Once you write the product structure, just verify 2 things. Number of carbons. How many carbons we have? Double the number of carbons as that of the reactant. So this is having 2. That means 1, 2, 3, 4. And check if it is beta hydroxy. If this is the functional group alpha, beta, beta hydroxy. Therefore, the structure of the product is correct. You can easily write the product structure for the bond line structures also will follow the same rules. What is that? This is an electrophile. This is a nucleophile, right? So you always write the electrophile carbonyl as OH. You don't have to write the hydrogen. It is understood that the hydrogen is here because it's a bond line structure. Now, identify the alpha carbon here. This is the alpha carbon. Alpha carbon is the one which will attach here. So, this is the alpha carbon, right? The alpha carbon is attached to COH. Now, the alpha carbon is attached to aldehyde and methyl. Don't forget about the methyl. Now, count the number of carbons. So, 1, 2, 3, 4, 5, 6. And also check whether it is beta hydroxy or not. Yes, it is a beta hydroxy. Therefore, this is the correct structure of the product form. Same way we can write for ketones also. The ketone taken here is a acetone, right? So, what you have to do? You have to write the 2 carbons like this, right? Methyl and methyl, methyl and methyl. What about this carbon? It is going to form OH. Now, what about the other one? Check for the alpha carbon. This is the alpha carbon, right? So, if this is the alpha carbon, then COCH3. Now, count the number of carbons. 1, 2, 3, 4, 5, 6. And check whether it is beta hydroxy. If this is alpha, this would be beta, beta hydroxy product. Same way we can write for the cyclic structures also, right? So the given molecule is a ketone, cyclohexanone, because there are 6 carbons. Now, this is the alpha carbon which is supposed to attack here, right? So what you have to do here is you have to write OH over here, right? So this is the carbon, right? So here. So you just simply write down the cyclohexane. If this is a carbon attacking the carbonyl, adjacent to that, either you write here or here, doesn't make difference, okay? Like this. Now again check now. There are 6 carbons, no doubt. And if this is the alpha carbon, this is the beta carbon. So all the product structures are correct. So this is how you write for aldol addition, right? How to write for condensation? We know that condensation happens when you add few drops of acid followed by heating, right? This is a condition for the condensation. In condensation, you are going to remove H from alpha, OH from beta. So how do you write that now? CH3. You have to form a double bond here. So CH double bond CH, CHO. This is the alpha beta unsaturated aldehyde. Same way we will write for the other products also. So you see there is a methyl over here. Still we have one hydrogen here. H from here and OH from here will get eliminated like this. If you want, you can again cross check for the number of carbons. So 1, 2, 3, 4, 5, 6 like this. Same reaction conditions, right? So you can write down the number of carbons, say 1, 2, 3, 4, 5 like this. And then there is one more methyl here. And between these two, there is a double bond between alpha and beta. What about here? So same reaction conditions. You write down cyclohexane structures like this. And then the ketone is unaffected, but between alpha beta, there has to be a double bond like this. Students, it's better to learn how to write the aldol condensation product in one step without writing the beta hydroxy product. This will be very helpful for your competitive exams. So how to do that? Just follow this technique. See, the two molecules of reactant are going to react in presence of a base, which is a catalyst, followed by the condensation to form alpha beta unsaturated product. So how to write the alpha beta unsaturated product? You write one of the molecules as it is, where there is a carbon oxygen double bond. There you write carbon carbon double bond. So here the carbon carbon double bond is formed at the alpha carbon of the other molecule. That means what? Whatever carbon you are going to write, now start repeating from here. Okay, so that means this is the one which is attached to an aldehyde CHO, and the other side it is attached to isopropyl like this. Because you are going to remove one oxygen and two hydrogens from here to form a water molecule. That is nothing but the condensation. So you know that condensation is when two molecules, when they form bond, right, they eliminate a small molecule like water. So this is the final product. Now let's check for the second molecule. You write down this as it is. Wherever there is a carbon oxygen, there you form the carbon carbon double bond, right? And now you see, if this is alpha beta, right, so it will be always attached to the functional group, that is ketone. And where is the methyl group? So it is opposite, right, periplanar direction. So here, this is how you write the product. Now let's check for the last molecule. So here we have aromatic ketone, right? So you see here are the alpha hydrogens, right? So carbon oxygen double bond, you make it carbon carbon, right? And this will be the alpha carbon. So therefore it must be attached to a ketone like this. And then the ketone is attached to what? A methyl group like this. So outside we have two carbons. That means there has to be four carbons here. 1, 2, 3, 4. And look at this. This is alpha beta unsaturated. Everywhere it is alpha beta unsaturated. So this is how you have to write the aldol condensation products in one step. I hope I made this clear to you, and if you have any doubts, you can comment them in the comment section. In the next video, we are going to discuss cross-aldol condensation. That means when aldol condensation happens between two different molecules. Thank you for watching this video. Until next time.